Hello students, this is topic 1. This is topic 1 of kinematics. This is topic 1 of kinematics. This is topic 1 of kinematics, and the name of topic is, this is very first topic, so it should be distance and displacement. Distance and displacement. This is very first topic in kinematics. आप हमारे पिछले लेक्चर्स में आपने एलिमेंट्री मैथमेटिक्स फॉर फिजिक्स कंप्लीट किया 17 टॉपिक्स में. देन आपने यूनिट एंड डायमेंशंस कंप्लीट किया. देयर आर 7 लेक्चर्स फॉर यूनिट एंड डायमेंशंस. नाउ वी आर हियर फॉर kinematics. And our target is to complete it in 20 or 25 lectures. Topic 1 is distance and displacement. इस पूरी स्टोरी को हम शुरुआत करें इससे पहले एक क्लियर डिस्कशन इस पहले टॉपिक पे. काइनेमेटिक्स जरूरी है कि हम डिस्टेंस और डिस्प्लेसमेंट पर एक क्विक क्वेरी बना लें ताकि हम काइनेमेटिक्स को प्रॉपर्ली आगे बढ़ा सकें. सो व्हाट इज डिस्टेंस एंड व्हाट इज डिस्प्लेसमेंट? अंडरस्टैंड इट बाय एन एग्जांपल. Let us consider that there is a point A and a particle moves from this point A up to a point B, and let the distance is 50 meter. After that the particle travels from B to a point C. This distance is 40 meter suppose, and finally particle returns 20 meter towards A, 20 meter up to a point D. Now in this motion, as we know that the kinematics is the study of motion. अगर मैं simplest way में बताऊं तो kinematics इसके just बाद अगला लेसन होगा न्यूटन्स लॉज ऑफ मोशन. देन इनमें से kinematics जो लेसन है उसमें हम डिस्टेंस, टाइम और एक्सेलरेशन पर एक क्वेरी करते हैं विद वेलोसिटी, और न्यूटन्स लॉ ऑफ मोशन में आप फोर्सेस के बेस पे एक्सेलरेशन और फोर्स पर क्वेरी. So kinematics is the process to discuss about the position of particle, displacement, distance, velocity, speed, and these things. So this is a case, a particle start from point A up to point B, then it moves from B to C, from C to D, then finally it ends up at the point D. Then our discussion is to make a difference between distance and displacement. We want here to make a distinguishment between distance and displacement. So what is distance? Distance, अगर मैं बिल्कुल simplest way में बोलूँ तो distance is total path length. Distance is total path length. Total path length is called distance. Since here particle moves from A to B 50 meter, then from B to C 40 meter, C to D 20 meter. So total path length of the particle is 50 plus 40 plus 20. So it is 110 meter. This is called the distance covered by the particle. The total path length of the particle will be 110 meter, and the same is called distance of the particle. But displacement is something different from distance. It is the direct path between initial and final point. It means I want to say that displacement is equal to, again, the path length. Path length, again it is a length, path length between initial and final point. Final point. So by this diagram we can see that this is 50, this part is 20, so this will be 30. It is 50 minus 20, and this vertical is 40, so by Pythagoras this will be 50. So displacement of this diagram will be 50 meter from the point A to D, but distance is equal to 110 meter. So we see that if a particle is moving in a line continuously, then distance and displacement will become same. But if it makes a turn at any of the position in its path, then you see that distance will always be greater than displacement. So the complete theme we can write in this manner: distance is either equal to displacement or it will be greater than displacement. या तो distance displacement equal होंगे. Equal कब होंगे? जब पार्टिकल एक स्ट्रेट लाइन में ट्रेवल करेगा, और अदरवाइज डिस्टेंस विल ऑलवेज बी ग्रेटर देन डिस्प्लेसमेंट. इट्स मैग्नीट्यूड विल बी ग्रेटर देन द मैग्नीट्यूड ऑफ डिस्प्लेसमेंट। यहाँ ये बात क्लियरली बता देना चाहते हैं कि डिस्प्लेसमेंट में हमने मॉडल लगाया है बट डिस्टेंस में नहीं, बिकॉज इन दिस अकॉर्डिंग टू फिजिक्स डिस्टेंस इज अ स्केलर क्वांटिटी and displacement is a vector, and it is not good to make a comparison between scalar and vector quantities. So make the mod of displacement and compare it to displacement. So distance will always be greater than or equal to displacement modulus. Modulus of displacement will always be less than the value of distance. Distance is a value only, it is not affiliated to direction. So this is the case. Now if you want to write the vector, since displacement is a vector quantity, and if anyone says you that write this 50 meter in terms of I, j and k, then what is your way to do this? It is, first you should write the distance AB as 50I, it is 50I along x-axis. After that the particle moves along BC, it will be 40j with negative sign, because the basic directions are I and j. These are the basic directions of I and j. Since particle is moving from B to C, so it will be minus 40j for us. If this 20 meter will be 20I with negative sign. So if you want to make the displacement vector AD in vector formation, vector form, then it would be 50I first, after that minus 40j, and finally it will be minus 20I. So finally it is 30I minus 40j. 50I minus 20I is 30I minus 40j. This is the displacement AD. AD is 30I minus 40j. So distance of the track is 110 meter, displacement is 50 meter, and this 50 meter can be written as 30I minus 40j in vector form. So this displacement AD vector is 30I minus 40j. So this is a basic difference of distance and displacement. यूनिट दोनों के लिए एमकेएस की तरफ से मीटर प्रोवाइडेड है, सेंटीमीटर, मिलीमीटर, किलोमीटर, these are the other units for both, but one is scalar quantity and second is vector. So अगर आप कंपैरिजन करते हैं तो डिस्प्लेसमेंट के मॉड्यूलस को आप डिस्टेंस से कंपेयर करेंगे। डिस्टेंस एक न्यूमेरिकल वैल्यू है, इसलिए उसमें मॉड की रिक्वायरमेंट नहीं है, बट डिस्प्लेसमेंट इज अ वेक्टर क्वांटिटी, सो टेक द मॉड्यूलस ऑफ दैट फॉर कंपेयरिंग इट टू डिस्टेंस. And if you want to find the displacement vector AD, then this is the way to find it. So this is a case to make a distance between distance and displacement. Distance is the total path length of any particle, but displacement is the direct distance, direct path between initial and final point. So that is distance and displacement. Similarly, one other example, if a particle moves in a circle from point A and approaches a point B diametrically at diametrically opposite point, then if speed of particle, suppose the speed of particle, or let us consider that the radius in which the particle is moving is 4 meters. Suppose it is moving in a 4 meter track, 4 meter circle, the radius of the circle is 4 meter. So in this example, if you want to find the distance AB, then you know that distance is path AB. It is path AB, and you see here that path AB is not the direct distance between AB, since the particle is moving in this track. So for finding distance, we should calculate the arc length. It means semi circumference, and this semi circumference will be pi r, because the whole circumference is 2 pi r. It will be 4 pi. So 4 pi meter will be the distance of this particle from A to B. But if you want to obtain the displacement magnitude, displacement mod, then it will be the value of diameter AB, and it is directly 8 meter, because 4, 8 meter. Displacement is the direct distance between initial and final point, but distance is the path length in which particle is moving, total path length of the particle from initial to final point. So distance is 4 pi meter and displacement is 8 meter. If you want to write the vector of displacement AB, it is AB vector, then it would be 8j with a negative sign. Again, I want to see that this is downward vector, so it will be written in minus language. Minus 8j will represent this vector. अगर पार्टिकल A से B तक जाता तो हम अपनी जनरल थ्योरी में से प्लस 8j कैलकुलेट करते. So this is a common difference between distance and displacement. आगे हम आपको अपने अगले लेक्चर्स में पहले काइनेमेटिक्स के बेसिक आइडियाज क्लियर करेंगे, देन आपको काइनेमेटिक्स के अंदर प्रोजेक्टाइल सर्कुलर मोशन तक की पूरी थीम प्रोवाइड करेंगे। हम बिल्कुल इसके पैरेलल IE रोडो के सॉल्यूशंस भी प्रोवाइड कर रहे हैं आपको। IE रोडो एक फिजिक्स प्रॉब्लम बुक है, तो इसके पैरेलल वो बुकलेट के सारे क्वेश्चंस भी सॉल्व कर रहे हैं। तो जो काइनेमेटिक्स के टॉपिक पढ़ें तो काइनेमेटिक्स से एफिलेटेड प्रॉब्लम्स भी साथ में करते हुए चलें।